Hey everyone, this is Mr. Dan with Touch Technologies, and we're going to be talking today a little bit about memory management. Memory management's a real important aspect at runtime for any programming language. All kinds of things use memory, all kinds of objects and strings and tons of stuff uses memory management. And so when we designed Sheerpower, we spent a tremendous amount of time setting up our memory management system and doing extensive testing on that. And so that's part of today's talk, will be memory management. Thanks for the memories. So Sheerpower goes to great lengths to avoid memory allocates and deallocates. Those are very expensive. Allocating memory from operating system or returning memory is CPU intensive. It requires a lot of work. The fastest thing to do is to simply not do it at all. When Sheerpower starts a program, it carves out multiple memory pools and assigns characteristics to each of those pools. There's a code pool, that's where all your code that you're generating goes, a data pool, a string pool, a cluster pool. There's about 15 pools in total. The handling of each pool is based on need. For example, memory is rarely given back to the code pool, but it's often given back to the cluster pool because you're creating and deleting clusters and things like that. So therefore, they have vastly different characteristics. So here's some of our pools. By giving each pool its own characteristics, Sheerpower is able to optimize the use of that pool. The result is faster runtime memory management. It's very, very critical stuff. When memory is requested, such as when creating a new string, Sheerpower selects the appropriate pool and overallocates the requested memory for the string. Later, if the size of the string is reduced, Sheerpower rarely needs to reduce the allocated memory associated with that string. Instead, it notes the new string size, leaving the memory allocation alone. If the string needs to grow again, often there's no need to allocate new memory, so that avoids a memory allocate. Instead, the previously allocated memory is used and the string size is adjusted. So here's an example of the efficiency. So I've got a counter here from 1 to 1,000. S1 is going to be string 1, S2 string 2, S3 is the concatenation of string 1 and string 2, and I do this 1,000 times. At the end of the 1,000 iterations, Sheerpower will have done a total of 5, not 5,000, a total of 5 allocations and no deallocations. Since Sheerpower does not use a data stack frame when calling routines or when processing parameters and private variables, it's able to perform further memory optimizations upon program startup. All this effort is done to reduce the overhead and frequency of memory allocates, deallocations, and concurrency checks. Sheerpower uses the following methods to achieve its high efficiency of memory use. We have an optimized, what's called a boundary tag memory management scheme. You can look that up, obviously, in Google if you want to know the details. We also have multiple memory pools, each with its own characteristics. We also do memory pre-allocations, over-allocations, and something called lazy deallocations. A lazy deallocate says that you don't deallocate memory until you're forced to. This way, there's a possibility you can use that existing memory for other uses. And we have more optimizations as well. The use of these methods has eliminated the need for a memory garbage collector and all of its associated overhead. If you look in YouTube and other places on garbage collectors, you'll see there are extensive tricks and tips and things like that for programmers so they can make their memory allocates efficient to avoid garbage collection. Sheerpower doesn't have this problem. With Sheerpower, programmers never need to learn tricks to deal with memory and performance issues. So that's how our memory allocation system works in Sheerpower. Please subscribe and leave comments. We really do want to see lots of comments, so let's hear it from you. Thank you so much.